Yes. You're ready now. Go ahead. Another day in the field. The secrets of ancient civilizations are close.
Close, but very nice mountain of dirt. My arms are like overcooked spaghetti.
We dig it up, we bring it out, we sift it grain by grain. No wonder we're tired.
If only dirt could lift itself out.
Yep, not happening.
Why are you guys working like it's a Stone Age? It's the 21st century. We have technology to do better than this.
I'm hilarious. How's it work?
It's a portable automated module sifting system that has a vibrating sifting motor and a conveyor belt to bring dirt up from the pit.
So no more bucket trips?
Not unless you want to work out.
Let's see how this works. Loading dirt into the sifter.
It drops it right into the vibrating sifting motor.
Look, an artifact. That took seconds.
That belongs in a museum. Now that's how you get it done easier and faster. But most importantly, safer.
The Swifter sifter moves through automatically, so we save our energy and stay safe.
And we make discoveries faster.
Get here's while supplies last. On sale for 24 hours. Goodbye. Okay. That was our skit. Now we're going to go into our presentation. So we started out by asking a question at the archaeology Reddit forum. What is a problem you face in the field? They were like a whole bunch of ideas: AI aids, site preservation, drones, robots, VR and AR. All are very good ideas, but they're also already in progress of being solved. So we tried to find something different. Then we found our first expert, Malin Panzar, a Swedish archaeologist who specializes in the study of bones. And she told us that her sifting takes a long time and it's incredibly bulky to carry in and out. As an archaeologist, she often has to dig a quadric meter and put it into baskets that are separated from the sifters. Transporting the soil to the sifters and then hand sifting it is a significant amount of her time. So that's why we have our solution, the Swifter sifter. On to you, Jim.
Thank you, Ryan. So after Ryan stated our problem, we went through the scientific method, researching and getting our problem, researching to get our solution and our proof of concepts. So after that, we asked our expert Mullen for intel. She said that the top priorities for our sifter was it does not damage the artifacts, reduces manual labor, increases safety, and increases speed and efficiency of sifting, portable, lightweight, and modular. The portable fact is that it folds up and is easy to carry. It is lightweight and practically we can carry it in as you saw on Jeffrey. And this is modular, which you don't have to have a conveyor belt. You can do surveys with it. And after that we went to our iterations of the sifter designing with drawings, CAD, and final prototypes. Then after that we have our Lego proof of concept that actually works. And that idea is also how we got our first prototype design. It has a vibrator motor and just some wood stuff. We went to our expert Mullen about this and she helped us upgrade the design. So we added folding legs and a vibrator motor. Onto Jeffrey to talk more about design.
The Swifter sifter went through multiple design iterations. We started out with sketches, moved on to 3D CAD models, and then built full physical prototypes. We built our prototype 1 and showed it to our first expert, Malin Pantazar. She had some ideas on how to improve it and for the team, and so we built prototype 2, which is what you see right here. It has some improvements over prototype 1, such as being foldable, being portable, rechargeable, and having backpack straps. The Swifter Sifter also has been tested to see how gentle it is on archaeology. We got some pottery shards, painted the edges red, and ran it through a Swifter Sifter in our soil mix. After running it, we found no new cracks along the edges, meaning that this is safe for archaeologists. Right now, it is also available on GitHub so that archaeologists can build it out in the field. Thank you for your time. We are ready for questions.
Awesome.
My first question is, I see the backpack straps. How much does the whole thing weigh?
We have not measured it yet.
Pounds, maybe, around
Uh,
there.
We haven't measured it yet, but it is lightweight enough for even a kid to carry around. So it should be light enough for archaeologists.
And I'd like to add on to that, Don, that Jeffrey was carrying both ends, so if he's capable of it, then
What resources did you use for your research besides your experts?
we
Sorry,
looked
I
at,
might have missed it.
We use the archaeology Reddit forum.
we also used videos for our project too. We watched videos and some ideas for our sifter.
So when you were designing all this, was everybody included, or was it kind of one person's in charge? How did you structure that?
Everybody.
Everyone was included,
Yes.
and we voted on our designs.
Yeah, everybody voted.
Sorry, I'm just trying to think of questions for motivation.
Really good.
You're gonna have to give us time here.
Take all the time you need.
So what are you most proud of?
I am most proud of the building of this sifter table and watching it come to life.
Did you guys
I'm
do this
most
in your
proud
garage
of
with
the
your dads?
electronics in this little box.
I'm most proud of that an archaeologist actually liked this idea.
Yeah.
What was your last prototype? 2 or?
Two.
Three.
Yes, technically,
Two
you
and a
can call
half.
this one three.
Okay,
I'm gonna call it
so
2.5.
based, since your last prototype, this is prototype 3, yes?
Yes,
Okay.
it includes.
So, why did you upgrade it from prototype 2?
Because we wanted to keep iterating, like, we added the leg lock so you can carry it and it won't flap out, and the backpack straps so you can carry it in.
And this is also an example of the scientific method.
And then, if I may add on to that, we also iterated on this design to add a conveyor belt so that archaeologists can get it into the Swifter Sifter easier and faster.
And when we were talking to our archaeologist Eric, which you didn't get to, he said that this is good for surveys, but since we were making this modular, it's good for surveys and long-term dating.
So you said you also worked with another archaeologist, Eric, correct?
Yes.
Yes, we have two
Okay.
archaeologists.
Yes.
Who other teams may mention.
How did you find your archaeologists?
Well, we found archaeologist Eric. He works for the Tennessee archaeological dig sites, and we were looking for more archaeologists to talk to, and we found our archaeologist Mullen, which one of our teammates had a connection with. So that's how we got him.
How did you find Eric? Was he on the Reddit? Is that, or?
He was not on the Reddit. We had found him online on
okay.
a website.
And you said you tested this,
Yes.
Yes, we had tested this.
and how many times?
We tested it on garden.
We've tested it around 12 times.
Yes.
So down here, we tested it with soil, and it worked. And we are gonna improve on the concept because our biggest problem right now is red Alabama clay. So
That's everyone's problem.
yeah,
And
it's
sorry, go ahead.
it's okay. So we're gonna plan on upgrading our design so we can work with the red Alabama clay.
Will this work for Cause you said soil, will this work for like muddier soil?
No.
We haven't tried.
No? Okay.
No.
I just wanted to,
We're gonna try to look into some ideas for that too.
Yeah, that's our, if we make it past considerations.
any other questions?
No, good.
Yeah.
Alright,
We're all good, so you can go ahead with the robot if you like.
Okay, so our robot is a box robot design made by Next Gen Robotics, and you can see it here. However, it has undergone some modifications, such as adding bulkier tires for better traction, and adding dual sensors in the front so that it can sense colors and distances. Yeah, right now, it uses two sensors, the yaw sensors and the dual sensors in the front. And, yeah, that's about it. Yeah, off to you, Jake.
Thank you, Jeffrey. So I'd like to talk about our code. So our previous code was 5 prime. Easy, good starter for our robots. But we ran into some issues. Going straight was inconsistent, turns drifted, and arms were just not going to the right place. So we found our solution, Pybricks. Pybricks uses MicroPython and block coding. So if anybody codes in Python, it can code Python. We got a menu code from a team called Monica Halo Encrypted Incorporated, and this is what it allows us to run multiple missions rather than just one. We have included a gyro sensor because it was not in there in the first place, so it allows us, our robot, to be more accurate. A load program function, which allows us to basically load our program, otherwise the robot wouldn't work. And the program numbers to add on missions for our board. And here's some samples of it, and we are ready for questions.
Yeah, we also have a bunch of attachments. One we used to solve a mission that one of the judges last time asked us, hey, what's a mission you struggled with? And then reiterated on this one. So we used a long arm on the side to flip it up. So that, I also consider that my favorite attachment because of its usefulness and reliability. Yeah, we're ready for questions.
what process did you use to determine what missions you were gonna go do on the board?
I can take this one. So we determined them by several key factors. How easy they were, how far away from the home base they were, and how many points they gave. So let's say the what's for sale mission. It's close, it shouldn't take long, and it gives 30 points. Pretty much all the missions do though. We're counting for this year.
Do you do all the missions, or do you only do,
We do a lot of missions, but not all of them.
Why did you use the sensors that you use on the robot?
We are using our sensors for some of the bigger missions that can require some lineup, so that we can detect colors, distances, and overall just improve reliability.
Plus, I would like to include that these are competition legal sensors. They're from the powered up. They're
Yes.
from the powered up.
No?
That's a good thing.
Yep. But it's from the powered up set, so it allows us.
Yeah,
So,
I remember that. And you said you improved on a mission from last time,
Yes.
and you were, I'm sorry, I'm kind of looking. It's the second one on from the left, right?
Well,
Yes, that one.
yeah, we
Okay.
lifted it from under the neck with the.
Can you go further into detail on how you, improved on that with its code and arm?
Yeah, so we drove to the Indiana Jones minecart thing. And we did a multitask to lift up Indiana Jones while we were there because it's like right there. And so we lifted it from under its neck instead of on the little arm, which requires an insane amount of force to push. So, and the neck just requires leverage. So the neck was the easier way to go, and we went with the neck. And we have really good reliability on it.
Go into more detail about, you said you changed over to the Pybricks coding. What resources did you use other than that team?
Well, we used Monica Halo, of course, but we had some other resources. We used some files, some README files from the Pybricks software, where we got it from, and we also used GitHub to save our code too. So it wasn't just Monica Halo.
Did everybody have a part in building and coding and?
Yes.
Yes.
Everyone was coding their own missions.
Yes, everybody code their own missions.
Everybody
I-
codes, everybody builds, and everybody builds attachments.
Yes.
And
everybody
how did you choose who did what mission? Or was it just like, oh, I really like this mission?
Can I do this one? Yeah, that's pretty much our process.
How did you track how you tested your success? You said you had to go to a different software because it couldn't turn and what have you. How did you track your test results and your, what needed to be improved?
We run a robot 10 times, and if it gets 8 times or more, then it's good, but if not, then we need to run it until it gets 80% reliability.
So based on the last competition you went to before state, what were some things you learned about your robot that you improved on, not including what we already talked about with the whale?
Did you add any missions between then and now?
We added a couple of missions. We combined codes, and robot-wise, we didn't do much, but we did make some changes before we came to competition. We were solving an issue with the wires because we found out that those were getting in the way, and we're trying to make some room so they don't drag on the tires, preventing us from doing missions more accurately.
The wires are always a problem. They're always getting in the way.
Yeah.
And what was like the biggest thing you learned from the last competition to now?
Well, it'd probably be
Charge the robot before competition.
well. I think probably not stand in front of the post people.
Hey, but you had that little pointer. You had that pointer.
It's a good archaeological tool.
Exactly.
Take a little hold of it.
I think that's all I got.
What were some of your other attachments that you have? And
We don't have them with us at the moment.
Yeah.
We forgot them in the cafeteria.
that's okay.
But we have multiple attachments. My personal favorite is the drill because it looks like a drill and it does the angular armor attack mission.
My personal favorite, I don't know the name of this mission, but it's in the like top or front left corner, topsoil removal, I think it was. It uses a one-way arm, so it can grab the topsoil and then pull it out without worrying about losing it. That's my personal favorite.
Do we have any more questions for Robot?
No.
Okay, because I do want to go back to innovation real quick, because I just remembered a question I wanted to ask, but I forgot.
Yes.
How much do you think it would cost to make and give to archaeologists?
Probably about $200 for everything.
Well, we haven't assumed the exact price, but the military backpack frames we saw online were pretty expensive. Pretty much like $80. So this thing's gonna be like cheap enough to the point where they can get it.
Cheap
And
enough.
we're also gonna release the blueprints online on GitHub.
We already have
We already
released
have.
on GitHub.
I'll have to look at it after the competition.
Yeah.
And how did you make the conveyor belt? Is it, cause I'm seeing blue.
So the blue is actually pool noodles.
That's good.
And we have some rubber bands on it, and we switch it out with grid patterns for shelves. And we have painter's canvas as the pulley. We made a locking system, the dirt buckets, and we have tape and that pulley.
How powerful is the, I forgot what it's called.
This thing
The
can learn
sifter.
to print out.
Yes, thank you.
Yeah, it has a
Fully-
button, it's a vibrating motor, and
Fully-
it has a stand on.
Yeah, it's a fully waterproof, dust-proof container, custom soldered. It is able to last 10 hours, continuous sifting.
Yeah, like, you have different buttons.
Okay.
And we actually have dirt with us to demonstrate. So
But
Go
we
ahead.
decided not to make the classroom.
Classroom dirty.
I'll
I did,
I'll get a broom.
yeah,
you'll get a blue.
if you wanna do that, yeah.
I'll get a broom.
I do have a question, back on the robot.
Yes.
You mentioned a couple of the sensors. Can you describe more about which sensors you have and what they allow you to do?
So we have 3 sensors. We have color sensors on the bottom and a distance and color sensor on the front, and we have the gyro sensor. So those are the 3 sensors we're using right now.
And how do you use them in your missions?
Currently, I don't know why I said we're using the distance one, because we don't use the color ones on the bottom actually, because the board this year, you've probably seen it, it doesn't have many lines. So, we can't really do much this year. So, and distance wise, we're gonna work on that, we're gonna try to get some missions done with it, and we're gonna work with it. So now we are able to demonstrate our conveyor belt. Right into the system. Of course, we'll need a bigger dirt bucket, but
Yes, bigger dirt bucket, but we already
you see it works.
artifact showing ourselves. And then one thing I would like to add, is we have,
Sorry.
we have nameplates.
So
So-
if you know, need to know where the,
Which
where
road it came from
yeah.
or something?
So like, for example, they can just mark it on the Sharpie like 5355, send it in with your load, it's too big to
And then you're-
sift.
and you're like, oh, this one came from pit 5355.
Yes.
And we also, but specifically red color because red is more visible and my mom likes red.
Red is very nice.
That's a good reason. Any more questions or not? That's all good? Alright, now time for feedback. You guys can, I'll clean that up. Now it's time for feedback, so we'll start with innovation first.
One feedback is, this is awesome. I think you guys did a really good job, especially like the iteration from Legos to actually being a real world, model. So I thought you guys did a really, really good job showcasing kind of how you started to design it and then how you came up to the solution.
I like the costumes, I like the skit at the beginning, and I thought it was great that you actually had a working, model of it. I thought that was very innovative.
Yeah, I love that you went from drawing to CAD, right? You said
Yes.
CAD?
Yeah.
Yeah, to CAD, and then to like an actual prototype, that we now have saw. So, One thing is probably pulling together like the costs, cause since you have like an actual working one, I would probably wanna see the cost of what it would be.
Yeah.
But other than that, like, you guys did good for innovation.
I would also, give more accurate weight estimate and
Yes.
size and everything, from a human factors point of view. Cause that's important, if you're a single guy out there trying to haul it out, you wanna know exactly, cause in addition to hauling this, you probably got your other tools, you got your water, you got other kinds of stuff that you gotta take with you. And so you might wanna get some more details.
And robot?
From a robot perspective, your presentation seemed to be, less developed, and you might wanna
Yeah, we don't
polish
have
it.
a robot here.
And-
Yeah, we forgot in the cafeteria.
But in addition to that, to just kind of start from the beginning and go through how you develop the process, or develop what your robot needed to do and how you got to it. It seemed to be focused mostly on your change in the software. Trying to think what was the other thing I wanted to say.
Do you have anything for robot one, two, three?
I think you guys did a pretty good job kind of explaining some of your coding, but I wish we went a little more in depth, just talking about fully how you guys work together for coding, because I know you guys talked about, you guys split up missions wise, but just going a little more in depth, that was the only other thing
Yeah.
for me.
Was it mission analysis?
Yeah, mission analysis, that was the other one. More depth on how you decided which ones you were gonna do and who was gonna pursue what, and how that got integrated into an overall run or, execution on the competition table.
I mean, I agree with everything I said, so they kinda stole my words. But I love that everybody had like involved in everything, innovation and robot wise. Teamwork, like what he said, teamwork was a big one, like collaborating on like, what's going on with everybody, but other than that, everyone was included and I love seeing that. And I love all of this, especially the scientific method and all your testing, so yeah, I loved it. And yeah, you're good, you can pack up, and I loved everything, and I wish you guys luck out there.
Yeah, you did a great job.
Again, we are so sorry to go.
It's all the time.